Here we go. So, if you're not here for our usual, ooh, my screen should be stopped sharing. It says I'm screen sharing. Okay, so hoping everyone can see my screen on Oregon Tech. Now then, week 4. Made it through week 3 with my recorded lecture, which I'm sure you all watched many times to get through. Wasn't sure about that week because it's really when you start getting to the tools we're using for the rest of this class. Week 4 is basically taking some of the stuff we learned at week 3 and expanding it into more and more complicated stuff. 3 and 4, we basically learned the tools that we're going to use the rest of this class going forward. We're just going to make it add more nuances to it and apply it to different types of scenarios and problem solving and stuff. But the basic toolkit is mostly complete after 3 and 4, and we're just applying that to other things as we go through. So keep in mind, see, as you come forward, we're going to, next week, just in chapter 5, you're going to have, let's see, let's pull up, I'm going to pull up the syllabus quickly for you guys. Let's throw it in here. Because one of the things that's next week, well, I have to take that draft off, getting down to the calendar, we'll have your article assignment 1 due. And I'm going to talk more about that on how to do some stuff next week, because it's not due obviously until the end of next week. But on Monday, I'll start talking a bit more about the article assignment 1. It's not too late to get into looking for articles. And if we don't go too long today, I'm going to go with some electronic resources at the library, those that haven't used them extensively, and show you how to look up some of the articles that are required on the assignment. So then the following week, you have a quiz, that first quiz, which if all goes well, will be on chapters 1 through 5. Again, let's do like everything else by the end of that week, but I'll open it up after class that week. So it should go at least through chapter 5, probably not chapter 6, depending on how much we get through. I say probably because if we hit any, I always say if we hit any hitches, and I said this the first day of class, where I feel we need more time on something, sometimes I will change the content of the quiz at the last minute. For instance, if we suddenly decide everyone's having a horrible time with chapter 5 and we need to spend another week talking about it, then the quiz will only go through chapter 4. So I'm not trying to be cagey about what it's covering, but if for some reason we had to spend extra time or the servers went down and everything failed in the world at OIT, we might have to change that. Barring unforeseen circumstances, though, it'll go forward as planned. So keep in mind that you'll have an assignment and to do next week, something in addition to the usual homework and the discussion group. And then the following week, you'll have an initial thing on quiz 1. So any questions before I jump into things on the assignment gamma? Seeing none, and I'll take silence as acquiescence. Okay, so the homework problems. I did a cursory run over them today, and most people did pretty well on these. There are a couple of areas I saw. I'm gonna get the grades in by Tuesday this week, and I'll talk about why after the breakout rooms later. So 13 or 3-14 was solve the diagram for Qs, assuming 6% interest rate. Now, as I get into this, as I've talked before, I'm not a big fan of these types of diagrams. I prefer the cash flow diagrams that we talked about at the end of that, where I have like nice Excel blocks in that period. But it's a common tool, so this nice little thing that says Q, essentially you're looking for something at this period, time period 0 is your goal, and your value in the future is 2750, 6% interest rate. So, okay, so you've got 4 periods because it says 0, 1, 2, 3, 4. So 4 periods in the future, again, doesn't tell you if they're months, years, or whatever. For the purposes of this problem, you don't care, but as it says in the text, unless you're told otherwise, assume it's years. It doesn't change the math a lot, but it says, always assumes it's going to be years, and interest rates are given at annual rates unless otherwise stated. So, there's, as we talked about you know, last week, there's multiple ways you can do this. And on the examples I gave in my lecture last week, I did on examples, I did them 3 ways. You have basically the math equation, which you can derive and is in the text. You have the interest factors or the period factors at the back of the book in the page, 600 pages that give you the factors, present value interest factors, future value of annuities and all that. And you also have Excel. So there's 3 ways you can do it. And just going through the homework, I have people who did it all 3 ways. And some people that did it actually did it through the math. Oh, so we got to ask Ray. And Wyatt's here now. Ray and Wyatt are here. Okay, we almost have a full crew. Whoops, where'd Wyatt go? I can't find him. So, oh, he was already here. Alrighty. So I don't care which way you did it. People on the homework, some use the Excel version, some use the factor version, and some people use the math to derive, you know, the actual factor themselves. Don't care which way you do. So either way it'll work, as long as you get there. As I said before, sometimes you will find a little bit differences depending on how you do it. Because if you're using the factors at the back of the book, quite frankly, it's going to be rounding sometimes. So, whoops, and Antonio's coming too. Okay, so you almost have a full crew. Now then, so don't worry, that's like one of the problems on this week's homework. The book had an answer that was derived by using the factors. And if you use Excel, you had it might be $2 or $3 off. So if you get something like that, it's just rounding on factors. Excel does it down to like 9 digits. Unless it's mine, I have it stop at like 6. You can manually set your Excel to stop certain places, just because for certain calculations I use Excel for, if you let it go on too long, it really gets onerous. So in this particular case, I did it 2 ways here. I did it, you have a present value here, factor here, and I used this formula. If you go, oops, where's my data, my function insert, formulas, where I pulled this up and just had the rate they gave you, 6%. They had number of periods, 4. And the future value was 2750. They gave it to you. So I typed that into the formula, and on Excel, because I wanted the present value, because they gave you the future value, and that's how I got the 2178. On the other hand, you can also go down, get that factor by going on page 641 and looking at 4 periods for the present, future, P/F, meaning what's the present value given the future value. And you get that factor and multiply 0.7921 times 2750. And so that's how you get 2178 in that case. I didn't put it into the math, but math will give you the factor. If you use the formula, you can get the same way and get that factor. So however you did it, I did it both just to say, hey, I did it both. But it was nice at the top of the modules. Well, I can always add, it should be in the announcements, but I can repost the link. But it's in the announcements. I'll repost the link for those, no worries. So that was problem 314. I don't think I saw anyone too many problems with that one. 315 goes into a student has inherited $50,000. How cool. If it is placed in the savings account and earns 3% interest, how much is in the account in 30 years? In this case, you're given an amount today, and interest rate is 3%, time period is 30 years. Again, you can do it 2 different ways. You can go on page 654 and look up the future value interest factor. FVIV is what we used to call it. They had the P/F and that type of stuff. In my days, it was future value interest factor, which is 2.427. So you have your current amount multiplied by 2.47 to come up with 121,350. Again, if you did it with the interest factor with the formula from Excel, the rate is 3%. They give it to you. Number of periods, 30 years. The present value is $50,000. They give you all those things. So just type those in, and it gives 121,636. In my case, you got it. The signs is just a factor of what Excel does, and I talked about that last week. And quite frankly, sometimes those arrow diagrams that I don't like can help, because Excel's looking at it from the standpoint of, well, in the future value, you're going to take out this money. So the account's going to be, at the end of the time period, you're going to take out that money. And so it puts a negative value. That's the rationale it does. So the one thing, if you want to keep all the money consistent sign-wise, you can put that in there, but it's trying to say the $50,000 in this case was positive. You're putting it in there, you take it out, you get it back. Or you can do it the opposite and say, okay, well, I'm getting $50,000 and I'm putting it in the bank, so I no longer have it in my hands. So it's negative. And at the end of that time period, you're going to take it out, assuming after 30 years. And so you're taking out of the bank, so you have $121,000 in your hands. That's the rationale Excel goes through, saying, hey, is it going to make it positive or negative in its calculations? So keep that in mind, because those signs can get tricky depending on what you're being asked, especially when you have cash flows that might be going in and out over time. So don't get hung up on the signs. It's trying to do it from the standpoint of basically the bank, if you will. And if you get into your accounting, it's debits and credits. So a debit for one person is a credit for the other person. So in this case, if I make it negative, I'm assuming I'm putting it in the bank, so it's not in my hands, it's in the bank, so it's minus from me, away from me. But in that case, it gets 121. Good example here of these two numbers. One's 350 at last three digits, one's 363. Once again, it's rounding. This interest factor goes 2.427, whereas Excel does it many 9 digits long to get more exactly. You won't get wrongly marked doing either one.
When it comes to noting, when it comes to like noting our homework and stuff, is it okay if we change so essentially how Excel has it in red, do we need to leave it in red, or can we change it back to black? We want.
You can change it if you want. My main thing is as long as it's consistent. Cash flows out one way, cash flows in the other way. As long as you're consistent in how you do it, it's fine either way.
Awesome. Thank you.
316. This one was, you know, the certain piece of equipment will cost $275,000 in 6 years. How much must you deposit it now at 8% to pay for it? I said to someone last week, boy, I want to know where they get their banking, because they get really nice interest rates. Okay, you got equipment that in 6 years will cost $275,000. How do you know that? Crystal ball. So, interest on deposit. Same type of thing as before. Present value, using Excel. Again, number of periods is 6. The rate, 8%. The future value is $275,000. So if you figure out how much you have to put in the bank today, well, that's that $173,297. Or you can take page 643, look for 6 periods, called N is 6, present value factor 0.6302, you get 173,305. So again, whichever way you do it, that difference between that 305 and that 297, rounding. They're both correct for our purposes. 22, this is the one that got a little tricky, but most people doesn't appear to have too much trouble with it. This one is one of those ones where you just have to sit down and think, what's it asking me? Because it can sound convoluted. You have a rich uncle gave Arnold $16,000 from selling an old family farm. wants to start college and have $12,000 available to buy a used car when he graduates in 4 years. Obviously, he's not going to OIT because we all get to borrow Ferraris when we graduate from OIT because we get high salaries right away. So he obviously went to Portland State instead of OIT. So you want to have $12,000 at the end of that. So if he earns 2% on a savings account, he wants to have $12,000 in 4 years. How much can he have now? Because he wants that motorcycle. How much can you spend today? So there's different ways you can set this up. Gift from rich uncle, new car at the graduation, 4 years of savings at 2%. That's a more likely interest rate nowadays. So what can you pay today? So present value of $12,000 in 4 years is, or present value of $12,000. Oops, sorry, I didn't want to use it on see it. $11,006. So $16,000 minus that is that that present value of 4 years is 4,914. So all I did in this version is, once again, present value, same as we've been doing before. Your future value needs to be $12,000 because he wants to have that. So in 4 years, interest rate is 2%. That means he's got to put this much in the bank now. So in 4 years, at 2%, he'll have $12,000. Okay, so you get an equivalent. Step one is getting that equivalent for today. Then the $16,000 minus that, these in the 4,914 that you can put in the bank, or should be put into his motorcycle. Again, if you want to use interest factor rates, you can still do 1.082 from page 634. And so $12,000 is equal to the gift minus the motorcycle amount times that interest factor. So in that case, you get 4,909. Doing the same type of derivation, except you're $5 off using the factor versus using a cell. Don't care which way you do, they're both correct. This is why I push being able to see your methodology. Oops, one new message. Great question. Is principal the same amount as present value? Sometimes. Don't take them as synonymous. Principal on the loan can be something principal means different things depending on the timing. So don't take those as synonymous, principal and present value. Principal may be the present value, but it's not going to be depending on where you fall in time-wise. And the books where we talk about, and I'll get to the lecture on this in a bit, present worth, the term present worth and present value. Present worth has become a more popular term nowadays. I use them interchangeably. Excel, if you notice, they don't say present worth. All their formulas have PV, FV, present value, future value. That's why they were created when I was in school. Actually, probably when my dad was in school. But okay, treat present worth, present value, future value, but in this case, I wouldn't call, well, principal, when you talk about principal, by itself, out of context, it really doesn't tell you as much because it's usually used in terms of principal and interest. So like the interest on a loan might be the amount of debt you have, but every month you pay on your mortgage part of that, and the chapter 4 derives that. I don't know how you make out that principal part. I don't think I do it in today's lecture. But you pay principal and interest on your car loan, principal and interest on your home loan. So principal may not be the balance, maybe the balance of you owe on your house, but it's not the balance of the loan amount. Your loan amount will include principal and interest. The principal part is the part that solely amount to the debt you owe. Hope that's a long-winded thing. Now then, last one was the preview on 4A, which was, let's see, that's where you get over 45 years. And what is the present rate? If it's a 4% interest rate, if you've got someone who gives you $6,500 raise every year, if you pass the engineering exam, and that's not an unrealistic option. If people mess up on this one, it's usually because they did not look at it. This is an A question from the very beginning of the chapter. It's per year. If people mess up on this one, it's usually because they don't do the per year part, and they'll treat it like, oh, I got $6,500 in the bank at 4% interest over 45 years. That's where people often mess up on this. I just did present value. Same as before, I got a present value of 6,500, but I got a period. I got a payment everywhere of the month. It's not just a present value calculation. I'm saying what's the present value of it is what I'm looking for, but you've got a payment every year for 45 years at 4%. So it says they'll give you a raise every year of $6,500 every year. People who just treated this often treated it just as, oh, I got this present value today of, or the 45 year of a single payment of $6,500, 45 years, 4%. But you get, it's a payment, ongoing payment every year you get. And that's where most people, if they messed up on this, generally will mess up on that thing that they just treat it as a single payment, but it says per year. They're trying to get you into the annuity thinking on chapter 4. So,
Professor, my thinking was that since it's a raise every year, you would assume that the second year, from the difference from that in the beginning would be $13,000 since it's a raise, and you would, you know, keep your raise if it's, and you get another 6,500 raise. Is that's what I thought it meant?
yeah, every year you get that additional $6,500 every year. So right. It's like an annuity over a 45-year period. You'd have $6,500 at years 1 through 45. Assume you work that long.
So it's more like a bonus than a raise.
Well, depends how you get your raises. I mean, you're probably thinking if I got a raise, I usually get like a 4% raise. But he's saying, no, I'll give you an additional $6,500 raise every year.
Right. So then year one, you would have, let's say you're making $10,000 a year, whatever, right? Mm-hmm. So then, yeah, that's what I thought. I thought it meant your pay increases by $6,500 every year, and it stacks every year.
You would get an additional $6,500 every year to your pay, because it says per year.
Okay. All right.
It'd be pretty awesome though if it stacked like that, and all of a sudden, you know, year 2 you got an additional $13,000, and
well, that would be nice if it was a gradient type of thing. Yeah, but it's in one sense it's just an annuity. Yeah,
you retire at 25 years.
Mm-hmm. A lot sooner. Then you get that Mercedes a lot sooner. All righty. Any more questions before I close this? Okay, hearing none.
So,
sorry.
What's the difference between future value and future worth? Like, that drove me nuts trying to figure
that's
out.
What I said a minute ago. The book uses the same thing with present worth and present value. I, for my purposes, treat them as synonymous. The change in future worth got more in vogue when nowadays we try to look at things philosophically, not just in number terms, but it might be what is the inherent value of something. It might not be in dollar terms. It might be assigning dollar terms to something, say, oh, how much is our goodwill in the community worth, if you will. And so what is the value of something like that? That's what really worth came into in the last 20 years. For our purposes, they're synonymous: present worth, present value, future value. From a calculation standpoint, it's not changing, and I prefer to use a present value because most spreadsheet applications and statistical applications will use the value and worth. But it's more of a philosophical change, not a calculation change. And so I wish they didn't use it, but because it does create confusion. What's the difference between value and worth? Well, we can get out Webster's dictionary and argue about how close they are in that. But it's more of a philosophical change, not a calculation change.
I'll say that's what was driving me nuts this past weekend, because our future worth is talked about in chapter 9. So I'm like reading chapter 9 from the index, trying to figure out a formula to use for the part B and C. And then I reread the homework. I was like, oh, we're not doing B and C yet.
Yes, yeah. But yeah, treat them as future value. I will use them interchangeably. Future value, future worth, present worth. Just treat it as a philosophical approach to valuations in numbers. They're trying to incorporate things that aren't just money. And I really don't think it did a great job changing the nomenclature, but I didn't write the textbooks. Remember the old saying, the only perfect textbook is the one you yourself write. Alrighty, so going to chapter 4. Oops, come on. Why aren't you going down? Oh. Oops. Oh, sure, my screen's frozen. I'm going to stop sharing, and hopefully it will go back. Why? Oh, give me just a minute. Why won't you close it? Just going to close a couple of things, but somehow it doesn't like something going on. Oh, it's doing the presentation. Why is it doing this? I'm trying to figure out. And PowerPoint. I'm going to close this and go back here and say, are you working now? All right, I'm going to try one more once more to share screen. Why this is doing this, I don't know, folks. I apologize. Now, can anyone see my PowerPoint?
Yes.
Okay, let's see if it works now. Okay. Not sure why that did it. It froze up for some reason. I have no idea. All right. Equivalents for repeated cash flows. So you can hear universal series compound interest formulas. Oh, wow, that's really cool. And we're going to really talk economic equivalence. This is an economics class, so we're going to try and figure out a lot of questions throughout this course about, okay, what's the same of this type of money or worth over a period of time compared to that type of money or worth. And so we'll go through that, talk about compounding periods some more, and how the payment periods and compounding are different to each other. So a lot of words on here, but we'll break it down easily enough. So uniform series compound interest formulas. Basically, uniform series, you'll hear the term annuity used a lot, and sinking funds and things like that. If you ever had a car loan or home loan or something like that, you pay the same amount every month for. That's what these A's are, annuities. These are amounts on an ongoing basis, the same amount paid over time, whatever time, 30-year mortgage, 60-month car loan, whatever it is. And we go back and forth saying, okay, like on your mortgage, if you want to pay back a loan, I'm going to pay you so much every month until it's paid off. Well, we have an amount today. What's that equivalent to how many payments over how many years? 50 payments, or you might have a $10,000 car. You're going to pay over a 60-month period till the loan's paid off. That same amount you pay every month on your car loan, that's an annuity. Those are the A's they have here. Mortgages, car loans, those are the most common things that we experience everyday life on this. So here's the math version. Cool. F for the factor, A for the amount, annuity, F, future interest factor, A, the annuity. One of these is saying, here's the formula, just saying, here's what the future of this many payments over this time. You have this F/A on 4 formula, which corresponds to the back of the book, those 600 pages where you have an interest rate over so many periods. And for an annuity, the future value of an annuity. If you know the annuity for this many periods, what's it worth? Sinking fund, I get a lot of questions about what sinking fund comes from. And basically it's an old term. Quote chat down so I can see your questions. But sinking fund usually refers to loans that you're paying off. And theoretically what's diminishing or going down is the amount you owe on your loan every month. When you pay it, it's going down, i.e. the loan amount is sinking, going down. Old term that people say, where the heck did it come from? It's been around for a couple hundred years at least, I think. Okay. Now then, first example in the book. $500 deposited in a credit union, and it pays 5% compounded annually, which we've got to start paying attention to the compounding as you're going forward. Remember, the book says assume it's annual unless you're told otherwise in terms of interest rates and compounding. So you got 5 years, and you have a nice little arrow part that the book likes to use. I put this in a little Excel spreadsheet, which is what I like to use. These both tell you the same thing. Okay, $500 a year for 5 years. Cool. How much do you have in the bank after that fixed deposit? Now then, I put negative here. Nomenclature reasoning for that is that I'm putting it out of my pocket into the bank. So it's diminishing my cash on hand, increasing the bank. So the bank would have $500 positive because it's in their pocket, not mine. Okay, technically I own it, but that's how I put the negative 500 because it's money going out from me as the person. So got a couple of different ways you can do this. You can get the factor because you want to know 500 months, how much it's going to have in the future of this annuity for 5 years. So you can go down to page 640, look up 5% because it tells you pays 5% compounded annually. And you go find the future, find F, given A. You're given A, as I said, $500 deposited at the end of each year for 5 years. Okay, 5 years, here's your factor. If you stick that in here, 1 plus 5% to the 5th power minus 1 divided by 5%, you would get this 5.526. You stick that number in there. So $500 times that F sub A we just looked at out of the back of the book. 5%, 5 is 500 times 5.526, which is 2763. So you can either stick those, if you don't want to trust the back of the book factors, you can do this manually and multiply 5.526 because that's what you'll get out of this formula, times 500. So at the end of 5 years, after putting $2,500 in terms of $500 a year for 5 years, $2,500, you'll be able to take out 2763. That's the much money you're going to have in the future after 5 years of $500 deposits. Or you can do my favorite version, which is the Excel formula. What is the future value of B2 at 5%, 5 years of payments of $500? So that gives you a future value of 2763. Isn't that amazing? This is nomenclature I start using a lot more nowadays because it's how the book does it. So I'm going to copy it a lot, what I do when I see it. And if people ask, why do I have different colors and different things? Here's my version. Let's view, zoom. Future value here. All these figures just come up here. A great way to start off with these problems is just using something like this, a grid that they give you, and just plug in what you've got. Because you're not sure, okay, am I really looking for the future? What have I got? Looking at, well, in this case, you're putting 5%. Okay, they give it to you. 5 years, you're paying $500. Present value, well, you don't have anything today, times 0. Cool. So what you're looking for is the future value, which is what I stick there. And so, again, same thing as before. I have a rate of 5%, periods of N, payment, again, I made it negative because it's going out the door. So no present value, because I didn't have not starting off with an initial deposit, because it says at the end of 5 years, so that means year 1, 2, 5. And I'm looking for the future value, which is why I put it in different color. You'll notice my nomenclature, I think I said this first day of class, and this isn't something I ask you to do. It's just something I do for myself, been doing it for years. I did to put my inputs with yellow background and blue letters, so I can find out my inputs on complicated sheets. This isn't that complicated, but it's something I use as a tool in much complicated modeling, so I can always find out where to put my inputs. I always have a yellow background with blue writing. That's just me. It's not a requirement. Don't get extra credit for doing it. It's just how I can find big spreadsheets, my numbers quickly. And the one I wanted is what I highlighted in green. Cool. Now then, uniform multiple cash flows. All right, here's where we do have to worry about present value and future value and stuff. And this is example 2, straight from the text. I'm on page, what, 113, if you want to go where they are. Okay, you get initial deposit. Then after that, you get 375 deposited monthly. Interest rate, 6% monthly compounding. Now then, I put this nice big sheet up here on the spreadsheet that has 48 periods, 48 months. And if you want to get microscope out, you can see at time 0, I have $685. Then 1 through 48, I have $375. All right, you could do that way and then discount everyone back. So basically, it's very similar to the previous problem of $500 a year for 5 years, except we have an initial deposit amount of money of $685. So here's the tricky part, and this is what messes people up a lot. You give an annual interest rate, but they're telling you it's compounded monthly. All right, so 6%, there are 12 months in a year. So you take your annual rate and divide it by the number of times it's compounded in that year. So 6% divided by 12 months a year, because it's saying monthly compounding. And as long as there's 12 months in the year, you'll divide it by 12 for monthly compounding. That gives you a 5% rate that you're actually going to use in your calculations, because you're having 48 months at 5% compounded monthly. So it's 4 years, but you've got to multiply, since it's compounded monthly, that's 4 years times 12 for a total of 48 months. And then, but you also have to do the opposite on the interest rates. The N goes from 4 years to 48 months because there's 12 months in a year. But the monthly rate goes from 6% divided by 12 to 5%. The N goes up for the compounding and the rate goes down each month. So don't get messed up on those two. Sometimes you just gotta sit back and say, okay, what the heck am I doing? So you've got basically 2 things to think about. If you do it manually, you can do your old $375. And what's the future of this annuity? At 0.5%, 48 months. But you also got to figure out what's the future value of that money you put in today. So it's a 2-step process if you do that manually. You can say, okay, what's the future, given that I know the present value is $685. I have that today. 5%, 48 months. So you've got to do both the annuity part and the present value of the initial deposit part, which works out, should be to 21,156.7, or you can use the Excel version. I say, okay, I had future value, but you can do it in one step. I've got a present value of $685, payments of $375. My number of periods is 48. My rate is 5%. You just showed to get those. So in one step in Excel, I get that 2157 or 21,157. That is the same as that 21,157. So in Excel, you can actually use, say, those are my payments for 48 months, 0.5%. but I also have a present value to account for as well. Now, it wouldn't hurt just to do this in 2 steps and say, what's my future value of 685, and then do a separate set of, if it helps you think through it, do a separate set of calculations for the 375 annuity. Either way is fine. You can do this Excel version in 2 parts, just like I did the other part in 2 parts on the manual calculations with the factors. You could split this and just add 2 and 2 and then add them together. Any question with me so far? I'm hearing that. I'm going forward. All right, so everyone's keeping up. Now then, 4.3. Now then, how much must Jim deposit at the end of each month to get $1,000 at year end? You're saving up for those tickets to the ball in December. All right, you need $1,000. How much do I put away each month? Okay, again, you can use an annuity factor. Okay, your future factor you're going to have is $1,000 in the bank. To figure out what the amount each month you have to put away is, well, you go down to that, say 628. It pays 6% interest compounded monthly. 6% divided by 12 is 5%, or 0.5%. Go to your 0.5% page or 0.5% page and find your annuity, your amount that goes into the bank each month, given that in the future, it's going to have to add up to $1,000. 0.0811 or 0.0811 goes up there. 1,000 times that is $81.10. So you're going to have to stick that in the bank every month, so you can put out $1,000 at year end. 0.5%, 5% interest. Or you can use Excel, same type of thing. You have N is 12 periods because it's compounding monthly, 0.5% every time you compound. You keep eating there for a year, so N is 12, compounded monthly. And that gives you 81.07, using the same type of thing, because this time you're looking for that payment. When you think annuity in Excel, that's the payment you're looking for. Either you have it or you're looking for it when it comes to annuities. So in this case, you're looking for the payment amount in Excel. That's why I have my one green here. I have the interest rate, have the number of periods, present value is 0. The future value is 1,000. So you stick that in the formula, this PMT formula, to find the payment. Again, think of a payment function, think of that as sort of the annuity. I would have an even amount I'm going to get every month. With me so far? Okay. Quick with gas going through these. Okay, machine costs $5,000 in the last 5 years. If interest is 8%, how much must be saved annually to recover the investment? Aha, now we're starting to get to real economic questions like that. Oh, Jacob. Jacob's here. Welcome, Jacob. So in this case, we're looking at it from the terms of recouping our investment. And this is where, going back to that present worth, present value calculation comes in. Some people are more comfortable saying worth because we want to save annually to recover the investment. Are you physically getting a payment every month for that? No, you're saying what's that 5,000 worth spread over that time. And that's why some people prefer the worth term is an example like this, because you're not physically, you're saying how much must I save annually? Well, saving doesn't necessarily mean you're getting a check for that. So they want to use that valuation amount. They want to say worth. Again, treat them synonymously. So what you have is the amount you have today, and you have 5 periods, and you have an interest rate annually. Unless it says otherwise, it doesn't say anything compounded. So you're assuming it's an annual basis. It doesn't say compounded, however, it just says annual, 8%, 5 years, 5,000. So once again, you can go back to the book and say, look at my 8% page and say, okay, I want to find the annuity given the present value. Find A given P. They like to use A/P. Cool. Well, I look up 5 years because N is 5, and I have my $5,000. So I need to find the annual amount that will be equivalent for that $5,000 purchase. So you can say, all right, 0.2505. 5,000 times that 0.2505 is 125,250. So meaning in order to recoup the cost of that machine purchase in savings, you better be able to document that you're saving, $1,252 a year to make it worthwhile for that 5 years. Similarly, you can use Excel. Oops. Say zoom. Okay. Oh, now I can't see. 8%, 5 years, present value of 5,000. So I'm looking for my payment function. Oops, where's my data? More of those. So I have to find out the amount every year, rate, number of periods, 5 years. Present value is $5,000. Future value is 0. Now, if you don't put anything in future value, it assumes it's 0. So, and the other question I brought up last week briefly, pretend for the time being, pretend that this type isn't here. Sometimes people get questions from people saying, how can we do doing this type 1 or 2? Well, we'll get to that. It's called an annuity due, and it has to do with the timing of payments, where they get paid beginning of the month, end of the month, beginning of the year, end of year. For now, ignore it. It'll be fine. But anyway, same using Excel. There's my factors, payments, and now I know this is the savings I'm going to have to document. And this is a problem that comes up in the real world all the time. Hey, I want to invest in this new whatever. What's going to save us? Oh, $500 a month. Cool. Well, $500 a month, that's probably going to be more than pay for itself if we only need $1,252 for the whole year. So how much is it going to save us per year if you invest in this? This tells you how much you better be saving or else to make it worthwhile. Okay. I'm reading through these fast so that without questions. So I'm assuming you're just absorbing this, either that or you're watching reruns of Seinfeld. Okay. So here's a good example because it involves multiple things going on. And we're starting to get, which went over at the end of chapter 3, this nomenclature becoming important. So there's a lot of stuff in you. A machine costs $30,000. Okay. And you're buying it today. Again, this is example 4.5, page 116. Okay. O&M, your operation and maintenance of it, is $2,000 a year. Your savings are going to save you $10,000 a year. At the end of the year, you can sell a machine when it's for salvage value, whether it be for scrap or to some other company that can't buy it brand new. Salvage value is what you can sell it for at the end of your useful life for it. You have a 5-year useful life because it tells you. Okay, well, interest rate is 10%. So what's the worth of this? What's the present worth? Basically, you want to see, is it working? Am I going to make money? So you got to get your cash flows down. And the book does a pretty good job of going through this. I put it in this table format. The initial price here is $30,000. Every year you use it. You buy it today for $30,000 at time frame 0. So 0, years 1 through 5, you're going to have to pay out another $2,000. But same time, you're saving $10,000 every year. And at the end of the year, on year 5, you get your savings, but you also get the sell machine for scrap for $7,000. So that gives you basically this last, when I say the amount column, is $30,000 outflow initially. You get a net of $8,000 a year for 4 years, and then $15,000 last year because you have your $8,000 savings plus $7,000 by selling it for scrap. And that's how I come up with this amount here. Cool.
Is it okay if we combine this 0 row and the first row?
The 0 row and the first row?
Like kind of just like move the 30,000, like say we just didn't have 0 and we put the 30,000 on row 1.
That's a very different thing because that row 1 is a period in the future. You're buying it today. Okay. 0 is that I'm buying it right now. If you put it into period 1, that means you're buying it end of next year.
Okay. Got it.
All right, so now then, here's what the book does. Present value minus $30,000 plus 10 minus 2,000, you're 8,000. So that gets you an annuity you're getting in every year. Cool. Present value of that annuity at 10% for 5 years. You go find that P/A on the 10% page, go down the 5 column, you get this 3.791 factor times that $8,000 you're saving every year for 5 years. But you got to add also, I got $7,000 I'm going to get, cool, times that, which gives you that 4674. This, you're going to discount this back. So what you're trying to do is saying, okay, my savings, the present value of my savings, P for present value of that annuity, because you want to get everything equated to that $30,000 outlay. So you're putting everything back to the equivalent of that 0 time frame. Basically, you have to say, okay, what all these things equate at the same time. So the present value of an annuity, that annuity is that $8,000 a year you're netting from the savings netting of the cost. You also got to discount that $7,000 that you're going to sell it for in 5 years. So you go down to your present value of a future amount. Future amount is $7,000. Well, the present value factor at 10% for 5 years, 0.6209. So you multiply that out and it nets to 4674. Did I do this in Excel? So here's the magic, oops, in Excel. Oh, come on. Maybe it's my mouse. You should clean it. You should clean your mouse every few years. Okay, zoom selection. All right, here's the thing I showed you a minute ago, 10%. So the present value is, again, okay, present value of cash flows, rate, number of periods, payment, future value. Cool. So that I can do it all in one step in Excel. Whereas doing it manually on the factors, you have to do the final salvage value and the annuity part separately. But I'm getting even payments, so I can put the payment in there. The future value is that $7,000 at the end of it. And that gives me this present value of 34,673, which I have to take away from, take away the purchase price to get that 4673. Again, gets you the same place either way, 4674.3. Difference is rounding. Came out to 74.3 using the factors. Came down to 4673 using Excel. It's just rounding. All right, and that shows everything here. How you do it, I don't care. Depends how your head goes. If you're not sure, break it down into 2 steps, because if you do it in 1 step I have, if you're not sure with the formulas yet, it doesn't hurt to do 1 Excel for the present value of the payments, 1 Excel calculation for the present value of that 7,000, then add them together afterwards. It gets you the same place. I just did it in 1 step to show you that you can. So now then, 4.6, rate of return. Now we're starting to cook with gas, and this is something you're going to see. And when at the end of this chapter, we go into internal rate of return and present value a little bit. I think in chapter 6 and 7, we have a whole 6 or 7, we have a whole chapter dedicated to present values and rates and that from what we call net present value. So we say, what's the rate of return? Essentially, what's the interest rate of return on that? You hear that term all the time in finance. What's the rate of return on so many, usually we talk about it in terms of bonds and stocks and stuff, but any payments, you can say, this is equivalent of this rate of return. It's not quite equivalent to saying what would the equivalent interest rate be on it. It's not quite there, but it's an overused term that you get used to hearing. You have a rate function in Excel. Number of periods is 5. The payment, $8,000. Present value, $30,000 outdoor. Future value of $7,000. And that can tell you what the equivalent rate is, in which case it's 0.1538 or 15.38% rate of return. This is a new concept we're talking about, but as you go through the rate, and you've all read chapter 4, this is the sort of interest rate equivalent to a little bit, but I don't think that's a good way of describing it. This is the rate we're getting on this investment. It's a dangerous statistic to use on its own, so be cautious of it. So that gets us down to the nitty-gritty on these block functions, as they call them. Basically because you can put the cash flows in a nice block, like I put that example of buying the $30,000 machine. You're gonna get a nice little block function that leaves it. Net present value. That's a fancy way of saying, of all those cash flows that we just used, what's the present value of that? And if you use net present value function on that range we just did, you can get, it will do a lot of those calculations automatically for you when you have uneven cash flows, essentially. You might have, because as we did that example, we had 30,000 out year 1, 8,000 4 years, 5th year is 15,000. Up until now, we've been talking about even numbers the whole time for annuities. When you look at that as a block function, you had 8, 8, 8, 3, 8, 8, then 15. Uneven cash flows. Net present value is a function you can use to get there in one step in Excel. Internal rate of return. That's the rate of return we're calculating. Essentially, I would say on a break even. Your internal rate of return is the break even rate of return. You might be making money, might be losing money, but if you're at the break even point, when your outflows and inflows match each other, that's the internal rate of return. Now then, so it's a present worth. You have two-step process, and we're going to go through these examples. Trickiness is that net present value works for all future periods. Periods 1 to n, whether it be 5 years, 48 months, whatever it is. You don't use it on the current value, your period 0, because you know how much the present value of period 0 is. You're in it. It's whatever it says. In that case of the example of the machine at $30,000, we don't have to discount that at all because we have it right now, today. We paid it. It's in today's dollars. Net present value is for calculating streams of unequal cash flows that happen in the future from year 1 on. Now then, and let's say I use the term present worth here because that's what the book called it in its definition. Present worth, present value, treat them equally for our purposes. So the present worth is 0 at the break-even point. So it goes from periods 0 to n, meaning when you get to calculations, you include that initial outflow in your calculations in one step. Now, this will make more sense when you do examples. So, straight out of the book. Here you have some uneven cash flows. Okay. Year 1 or year 0 is spending $200. Then because of that money you spent on a new lathe, say you have $30 year 1, $40 year 2, 50, 60, 70. Every year it goes up $10. Doesn't matter that it's going up an even amount. It's just different every year. You have a different cash flow getting back as a result of this $200 investment. So you have this function called net present value, where you have A1, 5% interest, and a range of cells. You just highlight this down here. So then you get net present value. It'll give you the net present value of years 1 through 5, this 30 through 70. Then you add to it the outflow. And this gets back to what I said earlier about make sure your signs are right and consistent. Negative $200 because you're paying out $200 for some reason. But the positive one is the flow you're getting back as a result of paying out that $200. So that's what I say, make sure your signs are consistent in how you treat it. Would it make a huge difference if you had the positive here and negative here? You would just get this negative number. So if you're on the other side of the person, trying to say, okay, I'm going to get the money, and here's what I'm going to give back to you. Cool. So you add the initial investment, that B4 right here, to the calculation of net present value. It says it's worth $12.25. The net of all this is $12.25. $200 and $212.25 is the present value of these, and you net it against the $200 you paid out to get your net present value of $12.25. This is why I give a dramatic pause. This is one of your fun things you can do. If people make a mistake on their homework, they will use net present value and highlight everything, including the initial outflow. Net present value, you don't discount the money that's today. You've got it today, you know the value today. Discounting all the monies in the future in that range of B5 to B9. So that basically tells you, hey, overall, over the 5 years, compared to what I paid out, yeah, I'm going to be $12.25 in the black. So again, here's what the function looks like. I did mine in 2 columns: price, the machine, inflow. I highlight, I pull up net present value in the functions, rate, 5%, highlighted in my case, G7 to G11. And you can already see there, right there, it gives you a preview of numbers here. And it's good, nice habit to get into when you're doing these formulas as you're creating them. It'll give you its estimate before you hit OK in this little writing here in formula result. It's a good way sometimes to look at it and say, okay, give a quick reasonableness factor check before you hit OK to make sure you haven't forgotten something. So that's your net. You can do it in Excel. It's a wonderful thing. So in Excel, same thing. You use 5, get the same answer that we did manually. So different cash flows. Another way you can do it, if you wanted to, is here. This is to show you essentially what the equivalent of what we're doing. Oops. View, zoom selection. Here's the way we did it using formulas. Net present value is here. Again, I said go to here, 5%, and I just highlighted these cash flows. Now then, what essentially you're doing the equivalent of is, in one step, is what this is on the one to the right if you did it on individual calculations. This 12.25 is the same as saying, okay, taking this $30, discounting it 1 year at 5%, which is the equivalent of $28.57. Taking this $40, discounting it 2 years at 5%, which is $36.28. Taking this $50, discounting it 3 years. Each one of these is an individual present value calculation. And taking this one, likewise. Okay, I can do an individual one. Take this, discount it back 4 years because it's from period 4, which is equivalent to that. All these add up to $212.25. So instead of having to do these present value calculations once at a time for each time period, given that it has a different amount, because it's not an annuity, it's uneven, I could have done 5 separate present value calculations, which is what these are. This one says, give me the present value of $70 in 5 years at 5%. And then you add them all up to get that 212. Or you can just hit net present value, which says, okay, this is $212 against the $200 you pay out. So that's essentially what this net present value function is doing for you. It's saying, hey, highlight all these. I'll give you the present value at whatever percent you tell me. And you don't have to do individual present value calculations over whatever time period. You highlight it, give it an interest rate. It says, here's the present value of these things at whatever interest rate you give me. Then offset against your outflow of cash at the beginning. That's net present value. It's a really handy tool. One of my favorites in the real world when you lean, because I hate to say it, but real world cash flows are uneven a lot. So, and especially in manufacturing, because who knows, these might be uneven because you're ramping up the manufacturing process, and the machine's going to save you more money in the future. And the more capacity you run, the more money you save, something like that. Who knows? You with me on this? I'm skipping through stuff pretty fast. Now then, internal rate of return. Cool, it's a beautiful thing. As a function, where internal rate of return, all you have to do is highlight everything, and it spits out a percentage for you. Now then, I have the same thing over here. Oh, did I put it right? Oh, I didn't. Tell me I didn't put it in here. Oh, I thought I put it in here. All right. Oh yeah, I did put it here. All I did on this one is put the IRR, internal rate of return, and highlight L6 through L7, this whole thing, and it calculates 6.9%. Now again, 6.9% philosophically is trying to give you a rate of return that you can equate to something. Now, one of the things that people often use, that I see it used, and it's, again, I think this is a very tricky statistic, but it's hugely popular because it's so easy to derive in spreadsheets. People often use this and say, okay, I can put my money in the bank and earn 10% interest, or buy a bond and pay 10% interest, or I can invest in this piece of equipment where I get only 6.9%. Or you could say, hey, in this case, the interest rate's 5%. So if I just put my money in the bank, I get 5%. But if I invest in this equipment, I'll get the equivalent of 6.9% return, as opposed to 5% of just putting the money in the bank. That's how it'll be frequently used. Corporations and departments frequently have thresholds that the finance spits out and says, we won't invest in any product that has a rate of return of 8% or more. How do you determine that? You do this internal rate of return saying, okay, at break even, here's what this would do at the break even discount rate. So if you, and this is where I blow people's minds, copy the 6.9%, and I stick that over here in this 5%, my net value goes to 0. Did anyone follow that? Okay, no one said yes. If I stick this internal rate of return into a net present value calculation, my net return is 0, break even. The outflows and inflows offset each other exactly, and that's how I get the net of 0. Here, undo that. At 5%, I get 12.25. The internal rate of return is that interest rate you can stick in to your calculations to get 0 net. Once again, I'll stick that in there, value paste it, and net present value of the inflows I get back equal the outflows I put out. That's just the internal, that's why I said it was this internal, the calculations. It gives you the interest rate that will give you a break-even amount. This is a dramatic pause. Only, okay, 3 people like it, but internal return is one of those things where I think by itself is tricky. Now then, because it's by itself, it sort of doesn't tell you about how fast you're getting stuff back, doesn't tell you how quickly you're getting repaid. It's a number that gives you a feel-good number. All right, just went through how I did it. Okay. Now then, anyone want to, we're going to come back and do a breakout in a minute. Before we do that, anyone have any questions? Before I'm going to give us anyone how long do we want, a 10-minute break or 15-minute break?
I'm good with the 10.
If no one else speaks up, then Ray speaks to all.
Yeah, 10's fine.
All right, let's be back at what? I got 4:12. We'll be back at what? 4:22. And